Okay, class, today we're going to talk about writing linear functions. Okay, so there's a couple of different types of problems that you're going to see when I ask you to write a linear function. You might see the function given as a table, a graph, or a description. And then I'll ask you to write the function from one of those things. You've already seen some of the different types. This video is all about writing the function when given a different type of problem. Okay. So let's say we have a table first. Okay, so from a table, or sometimes we'll call that input-output pairs, right? Here's the inputs, here's the outputs. Two steps. You just need to find the slope and then find the y-intercept. Now, to find the slope, we're looking at the slope formula here. So it's basically just rise over run, and we get the rise and the run from the table. So 4 minus 2.5 is y2 minus y1, and 6 minus 3, that's x2 minus x1. We do our calculations, and we get 1.5 over 3. Now you always want to reduce fractions to lowest terms. 1.5 over 3 can reduce to 1 over 2. And then from there, we want to find the y-intercept. Now this seems like the part where some people got stuck. Okay, the place to start when you're finding the y-intercept is to write out the generic form of the equation. Y equals mx plus b. And then we can start plugging stuff in. Well, we know m now is 1/2. So let's plug that in. M is 1/2. Okay? And then we have a whole set of input-output pairs over here. All we have to do is plug in one of those sets. Now, you can pick any one you want. As long as you know that the function itself is linear. Now, if the function's not linear, then you can't just pick a point from here. You're going to have to find some other way to find the y-intercept. But this one is linear, and we can tell because if you find the slope between any two sets of points, it will be 1/2. 6 minus 4 is 2, 10 minus 6 is 4, and 2, let's draw that out. That's 2. And that's 4. 2 over 4 is 1/2. You see, so the slope is going to be 1/2 no matter which 2 points we choose. Okay, so back to this. We can pick any input-output pair we want. So how about 6 and 4? We'll use that. So the x is 6, and the y, or the f of x, is 4. The input is 6, the output is 4. The only variable left now is b, so that will allow us to solve for b. That was our goal, find the y-intercept. So 4 equals 3 plus b, so b equals 1. And then there, now we have it. Okay, all that's left is to actually write the equation. We know the slope, we know the y-intercept, so y equals 1/2 x plus 1. There it is. Okay, so let's look what was next. So that was the table. Next one is the graph. Now, if you are actually better at doing the graph than the table, you could take the table and plot the points, and then use the graph to write the equation. So that's up to you. Let's look at the graph now. Then you can decide. Okay, so from a graph, notice the steps are the same. First, find the slope, and then find the y-intercept. Okay, so all we're doing is we're just looking at it in a different context. We've got the points laid out on the graph here. Now, in terms of the slope, you could, instead of just plugging into the formula like I've done there and got 1/2, you could just go up 1 and over 2, right? It's up 1 and it's over 2, so the slope is 1/2. That's all you have to do when you're looking at the graph. Now, as far as finding the y-intercept, it looks like it is 1/2, doesn't it? It looks like it's 1/2. But you can't be sure all the time. If it doesn't go through one of these tick marks, you can't be certain. So you still want to go back, write out y equals 1/2 x plus b, and plug in one of the points. So that's what I've done here. Y equals 1/2 x plus b, and then I took this point here, 3, 2, and plugged it in. The x was 3, and the y was 2. I just plugged them in, and now I just work it out. 1/2 times 3 is 3 over 2. I subtract 3 over 2 from both sides. 2 minus 3 over 2 is 1/2, because 3 over 2 is 1.5. So 1/2 equals b. So my equation is y equals 1/2 x plus 1/2. And that was just a coincidence that they came out to the same number on that one. Okay. Now, the last type of problem that we had was a description. So we looked at a table, a graph. Now, for the description, it's usually going to give away the starting point and the rate of change in the problem. So for this problem, Joe has a bank account with $3,000 in it. That's the starting point. And he spends $50 each week on food. That's the rate of change, $50 each week. So let's go ahead and take a look at one like that. Okay, so here it is, the same problem, just written a little bit bigger. What we did was, one more time, we said the bank account with $3,000 in it, that's the starting point. So down here you can see that's my y-intercept. And then he spends $50 each week. Now that's all important, $50 and each week. Right? We need to know how much he's spending and then over what period of time. So this is $50 per week. So 50W, I use W for weeks. Okay. Now in terms of the notation over here, the reason why I'm using M of W is because I'm saying the money he has left, M for money, after however many weeks. So that's why W. So M of W equals 3,000 minus 50W. Now notice we haven't actually answered the question yet. So how much will be left in the account after 6 months? Well, first we'd have to figure out how many weeks that is, because we're plugging in W, not M. We're plugging in weeks. So 6 months times 4 weeks per month would be 24 weeks. So we're finding M of 24. And that's going to be equal to $3,000 to start minus $50 times 24 weeks. $50 per week times 24. And I'll leave that to you to calculate the rest of it. That's it.